The digital world is a vast expanse of learning and entertainment. The big question evolving around digital technologies is how can we as teachers prepare our students for the digital age and support their development of digital technology skills? Without a doubt, it is critical as future educators to adopt and understand digital technologies to enhance and equip students with digital intelligences and to become global citizens.
Computational thinking is the prerequisite skill for understanding the technologies of the future. CT is becoming an essential skill for everyone as it's becoming more exposed within early education. To ensure students develop this ability at the early education stage, it is important that educators have an adequate knowledge about computational thinking and understand how to embed it within teaching pedagogies successfully. CT has the potential to advance students' problem-solving skills and abilities significantly as students begin to think in diverse ways. Lewin Fletcher argued that students need to learn computational thinking early and often, with an emphasis on understanding computational processes and not on their manifestations, in particular programming languages and skills of abstracting and representing information.
In relation to the proposed project-based lesson, Scratching the Surface of the Solar System, not only is computational thinking and digital intelligences enhanced, but the 4Cs are also integrated to support the development of digitally engaged students. In 2016, the World Economic Forum highlighted the digital intelligences and how to equip future teachers and learners with these for the digital age. Students communicate and collaborate with others using digital technologies, which highlight digital communication as well as adopt the ability to find, evaluate, utilize, share, and create content, as well as competency in computational thinking, which links with digital literacy, leading into the development of the 4 cornerstones of computational thinking.
In 2015, there was an international forum known as the Barefoot CAS, which defined computational thinking skills. CT concepts are the mental processes and tangible outcomes associated with solving problems in computing. There are 6 concepts which have been identified, which are highly useful in a wide range of projects and which transfer to other programming contexts.
Students engage with a set of computational concepts which are articulated by intentional digital leaders in the 2015 International Forum. The computational concepts throughout the proposed activity are common in many programming languages. Logic, algorithms, decomposition, patterns, abstraction, and evaluation are the specific computational thinking concepts that are articulated within the Scratch lesson. Each concept is practiced by the students through active engagement with each aspect of the coding lesson.
The proposed activity is developed around the integration of the digital technology Scratch. Scratch is a programming environment that enables students to create their own interactive and simulated solar system. Several concepts have been identified in the progression of the Scratch project, which is highly useful to achieve the lesson's intentions. Sequence, loops, parallelism, events, conditions, operators, and data are concepts which are applied through the integration of Scratch. Students are exposed to the development of these concepts within this lesson. This also allows students to become conscious about when and how they apply their ideas to achieve the lesson aims.
Within the lesson, students are constantly applying and developing computational thinking through the articulation of approaches. Computational thinking approaches are embedded into the teaching pedagogy to enhance students' knowledge and understanding of digital technologies. Within the lesson, students are constantly tinkering, creating, debugging, preserving, and collaborating to achieve the overall lesson aim. Students are consistently experimenting and exploring Scratch and learning about the forum independently and collaboratively. Through the exploration of Scratch, students participate in purposeful play. Programming on Scratch is a creative process which involves both originality and making something of value.
By articulating the computational thinking framework, the process of construction and design practices were engaged with during the progression of the lesson. CT practices are embedded within the lesson to support students' understanding and progression. Experimenting and iterating, testing and debugging, reusing and remixing, and abstracting and modularizing are the specific practices applied within the teaching pedagogy.
The dimension of perspectives is added to describe the shifts in perspectives that are observed in the students working with the forum Scratch, which included 3 elements. The 3 elements are prevalent within the lesson progression as students are expressing, connecting, and questioning. Students feel empowered to ask questions and make sense of computational ideas in the world as we recognize the power of creating with and for a purpose. Students are exposed to and come to the realization of computational concepts, practices, and perspectives in collaboration with a medium to create.
Given that computational thinking is becoming a fundamental skill for the 21st century, it is important to introduce these concepts in content areas at the K-12 level. It is important that as future educators, we develop a thorough understanding of computational thinking in the context of the subject matter they teach and are able to relay this knowledge to students. Ultimately, this coding lesson articulates the four cornerstones of computational thinking and supports the development of digitally enhanced global citizens.